guys. Today we'll be talking on differentiation. And here, if we have a function f of x will be equals to y, which is a function of x, possibly x squared plus 2x plus 3. This expression is a function of x because the unknown variables here are x. So, if we need to find the change, the difference in y as a result of difference in x, the resulting term here, dy over dx, is termed differentiation. So if we have maybe a line or a curve, this looks like more of a curve. This axis is y and this axis is x. So if we need to take the slope of this curve, then we need to put a tangent that touches the curve at some point here. So the slope now is the change from here to here divided by change from here to here. So differentiation has to do with the change that happens here from here to here if we consider the change between here to here. So if we drag this line this way, the line has changed. So differentiation now has to do with the relative change that will happen in these other parts as the result of us extending this other line. So if this is a function now, because this line now is a function of x, so how do we know the change that happens here in this other part of the line, the slope, with respect to the change that happens from here to here? That means we are considering the change here, and we are also considering the change from here to here. Because this other line from here to here has increased by this b, because this other line from here to here has increased by a. So the change from here to here, that happens as a result of change from here to here is what we call differentiation. And we have different ways of tackling differentiation. If we have the polynomial of this nature, this particular nature, we can use the standard approach of differentiation to obtain the derivative of this function. So, if we have this function y equals x squared plus 2x plus 3, of course, this is a quadratic in nature. If we need to plot this line now, it will give us either this term, and so on and so forth, because the highest power here is 2. So that will be a curve. How do we differentiate? How do we get the derivative of y with respect to x? So it will now be, we consider this term by term. We differentiate this one, we differentiate this one, we differentiate this one. So for the first term now, what we need to do is to multiply the power by the number. That will now be 2 times what we have here, x squared, and we subtract 1 from this power. That's for the first term. The second term, we do the same thing. The highest power of x here is 1. We multiply the term by that particular 1, and we put this particular term again, and we say 1 minus 1. For the last term here, which is 3, the power of x here, of course, is 0, because in indices, anything raised to power 0 is 1. So it's not as if there's no x here, but the power of x here is 0. And of course, this equals to 1. So we multiply this term by the power of x here, which is 0. and that will be times 3x. Of course, this is 0 minus 1. The first term here will now turn to 2x raised to power 1. Of course, is still 2x. The second term here is 1 times 2, which is still 2. And x here is raised to power 0. And the next term here is 0 because anything multiplied by 0 is still 0. So this further simplifies to 2x plus 2 because x raised to power 0 is 1 and 2 times 1 is still 2. So the derivative or the differentiation of this function y equals x squared plus 2x plus 3, which is here, is equal to 2x plus 2. That is for a polynomial of this nature. For other functions, maybe a function that is a product of two other functions, or a function that is being embedded, a function of another function, we have different ways. Or a function that is a quotient of two other functions, we have different other methods for differentiating the function. And we'll take up these other approaches in our next video. Thank you very much for watching till this time. We believe that you like our content, so subscribe to our channel.